When I took my CCIE exam many moons ago, you walk into the exam. It's a nerve-wracking experience, and you have to actually sit with the proctor for about 15 minutes before your exam starts, where they go over all of the rules of the exam. When the lunch breaks are, no talking, all those kind of things. And when you get to the lab itself and you look at the book, rule number one of the CCIE is no static routes anywhere at any time for any reason unless explicitly spoken of in the lab that are you allowed to use these things. Why would Cisco ban you from using static routes? Because you can accomplish anything using static routing. And a lot of time. So we're going to start now taking the concepts that we saw in the previous nuggets of subnetting and start practicalizing it, if I can make up a word. Start identifying these networks, putting them around our organization, and then moving data between them statically. So I'm going to start off by reviewing the purpose of routing, kind of just to get big picture, bring us back to it, how static routing can help us accomplish our goals of routing, and then look at some configuration and design scenarios for static routing and actually start doing it in a live environment. If someone were to ask me the question, Jeremy, what do you do? I would respond and I'd say I'm an IT guy. That's what I do. Now, is that a complete answer? Well, no, because they could say, well, can you screw in a light bulb? And I go, well, yeah, I guess I could do that too. And they go, well, can you ride a bike? Well, yeah. I mean, sure, there's all these little sub things, but when somebody asks big picture, what do you do? That's the answer. So when you say what is a router or what is routing, I mean, there's all kinds of sub things that you could do, but these are the main answers on the screen. Number one is stopping broadcasts. Could we live in a world without routers? Meaning, could we just have one big flat network that we call the internet, where everything is get rid of the subnet mask, right? There's no distinction anymore. Everything is just one big, one big network. The answer, if there was no concept of broadcasts, then the answer would probably be yeah. I mean, there's other considerations, but the major constraint is the more devices you add to the network, the more and more broadcasts there are, meaning messages that go to everybody. So the worse and worse performance it gets, to the point it would just become unusable. And our computers need that. I mean, they need some kind of big picture communication. They need to be able to talk to everything on the subnet, to resolve an IP address to a MAC address, or to get a DHCP request. I mean, there's all kinds of reasons for broadcast. But one of the number one goals of a router is to stop broadcast. So when we have broadcasts on this network right here, they stay there. They don't bother anybody else. The broadcasts in Arizona stay in Arizona. The broadcasts in the California office stay in California. The second thing a router does is find the best possible path to a destination. That's its goal, one of its goals. Does it always do that successfully? No. Why? Well, because there's all kinds of sophisticated mechanisms that go into that. I mean, if a router, let's say we have our router sitting at your house right here, right? And that connects to a service provider. Right? And they connect to other service providers, and they connect to other service providers, and we could have all this big spider web of all these connections. That's what makes the internet so powerful, is everything is connected to everything when you get there. I saw a picture once on a big poster, those geek posters you see in techie companies, and it was a map of the connections on the internet, and it was pretty much just one big solid blob of everything, and they actually had to use shading of colors to represent the different areas of that blob, of how many hundreds of connections were coming out of each site. So there's all kinds of different ones. So when it comes down to it, this router at the service provider has to say, okay, I think to get to Google, it's best to go that way. And this one says, well, I think to continue that journey, it's best to go that way, and this way, and this way. And even through all those redundant paths, eventually finds the best way to get to google.com, if that's where somebody ends up going. So that's one of our router's jobs. And then finally, a router's job is to move the unicast traffic between networks. I mean, if you think about it, it's like, okay, well, they stop broadcasts, and they also stop multicasts, which is a message that goes to a group of people instead of everybody, but they stop them by default. But, I mean, their goal is not to just sever network communication. Their goal is to say, if this happy computer on the left, 192.168.1.50, wants to speak to this computer over on the right, 192.168.3.50, we can make that happen. It can come to the router, and the router's like, absolutely, I can get you there. Let me send you to this guy, and he will get you along the way. If I want to directly communicate, that's a unicast, with somebody else, that's what a router can do. Well, now we come to our first method of routing, and that is static routing, the manual way. Now you might remember when we were talking earlier, I said switches, when you pull them out of the box, do what switches do. They switch. Now you don't get many benefits until you configure VLANs and all the other stuff we talked about. But a router, when you pull it out of the box, does nothing. It has no configuration. You have to get involved. So you're there with the console cable doing what you do. So let's say you pull this Cisco router out of the box, and you go into the fast Ethernet 0/0 interface, and you give it the IP address 192.168.1.1/24 or 255.255.255.255 or 0. The router immediately goes, aha! I am now one network smarter. I know how to reach one network, and that is 192.168.1.0. Remember the very first IP address, you can't use it because it identifies the network. That's what the routers use as kind of like the network name. Like, I know how to reach that guy, right? So you go in and you say, okay, well, I'm going to go under the interface serial 0/0, and I'm going to give it the IP address 192.168.2.1/24. Now notice I said you're giving it the IP address 2.1/24, but the router rounds that down. It goes, okay, well, if I have 2.1, then I must be connected to the 192.168.2.0 network. Aha! I am now one network smarter. But therein lies the problem, is the routers only know how to reach their connected networks. So, I mean, if this computer on the left wanted to ping something over here on the right, 192.168, 2.1, that IP address right there, it would be able to, because it would come to its default gateway, which is 192.168.1.1. Router would say, oh, you're trying to ping 2.1. No worries there. We can make that happen, and it's kind of, well, it's like itself, and so it replies back and says success. Now you might be saying, well, can't it ping 192.168.2.2 as well? Sorta. Here's what would happen, right? I initially was going to say that, but then I backed off really quick. If I said on this computer, ping 192.168.2.2, 2.2, which is over here on the other side, the ping message would go to the default gateway, and the router would be like, hey, I can totally get there. I know how to get 192.168.2. Whatever network. I know how to get there. So it goes, okay, 2.2. It sends out an ARP message saying, hello, 2.2. I've got a message for you. 2.2 replies and like, great. So the message actually comes right here from 192.168.1. Well, we'll give that guy 50. 1.50 as the source IP address. And it goes, hey, I want to talk to you, 192.168.2.2. The router looks at that IP address and says, well, that's great, but I don't know who you are. I don't know how to reach. So this router over here on the right is the one that pops up with a big question mark. He's like, I don't know how to reach 192.168.1.50. Matter of fact, I don't know how to reach 192.168.1. anything. I'm looking at my routing table and there's nothing there. Now, you and I are looking at this picture and you're like, really? Come on. Router 2, no, I forgot to give this guy a name. Router 2, it's right over there. As a matter of fact, you even saw it come in your interface. You saw it come in whatever interface that is, serial 0/0. Don't you know that you have to go back out that interface to get there? Nope. Routers aren't that smart. When you go onto a router and give it IP addresses, it says, okay, I only know, for instance, router 1 here on the left says, I only know how to reach 192.168.1.0 and 192.168.2.0. Router 2 over here on the right-hand side, did I say left, right? I think I'm just getting everything mixed up here. So router 2 on the right-hand side says, I only know how to reach 192.168.3.0 and 192.168.2.0. So I do not know how to reach this, nor does router 1 know how to reach this. Do you see the dilemma? We only know how to reach our connected network. So static routes allow you to educate the router to new places. What that means is you and I, as Cisco administrators, get involved to tell these routers where to go. Just clear off this gibberish. So if I'm wanting to use static routes, I would come to router 1 here on the left-hand side, and I would say, hey, router 1, to reach the 192.168.3.0 network, which is something that you don't know how to reach because it's not directly connected to you. it's directly connected to router 2, but you don't know that. So to reach this network, you need to go to 192.168 2.2. So essentially, we're using something router 1 knows how to reach something that router 1 didn't know how to previously reach. So on router 2, I'm going to have to come in there and say, router 2, for you to reach 192.168.1.0/24, that whole network. Now, again, I'm identifying the whole network, every device over here on that network. For you to reach that network, you need to go to 192.168.2.1. Now, does router 2 know how to get to 2.1? Yes, because it's directly connected to that network. It knows how to get to directly connected nets. However, it does not know how to get to the indirectly connected networks. Now, you can imagine. So to do an environment like this, again, let's make this real. Let's say this is an office in Arizona. Over on the right-hand side is an office in Texas. We connected a WAN link using some service provider in the middle, and we've got that all working now. But we need to tell the Texas router, here's how to get to Arizona and communicate to their devices and their IP phones and make phone calls, and here's how to get to their server. I mean, so that's the kind of scenario that we would be in. But you can imagine that when we get to a network the size of the internet, that doesn't work out well. Where there's literally millions and millions of networks out on the internet, we don't want to sit there one by one and say, okay, router, to get to the 1.1.2.5 network or 2.0 network, go to the internet. To get to the 1.1.3.0 network, go to the. I mean, we don't want to do that. It would take all day, all life. So what we would do for that is go to the router connected to the internet and use what's called a default route. Now, I think I did this earlier in the series, but if not, this will be the first. We actually go into the router and say, to get to the 0.0.0.0 network, right, go that way. I mean, the actual route. I mean, when let me get a little bit more into syntax, right? I want to, before we get into the live config, I'll show you what the actual command looks like. So on router 1, this is actually in global configuration mode. I go in there and so I'll put config. This is kind of the prompt we're saying. This is an iOS simulator. Did you know that? And I type in IP route. Think of that as like the I want to route command. IP route. I want to get to the 192.168.1. Or scratch that. We know how to get there. 3.0 network with a subnet mask. It'd be so nice if we could type /24, but we can't. With a subnet mask of 255.255.255.50. You actually have to type in the whole decimal subnet mask. So to get, if I want to route to this network, then I'm going to go to 192.168.2.2, which is this one. This is the actual command. This is iOS simulator, right? This is the actual command that I would type in on router 1 to make it happen. And I would go on router 2 and type the same thing, but instead substitute 1.0 and substitute 2.1. We're going back the other direction, right? So that's what it looks like to put in a static route. So when it comes to a default route, we come to the command. It would be IP route, and the command is actually 0.0.0.0 as the IP address. Let me get this little arrow out of here. Then we would type in 0.0.0.0 as the subnet mask, followed by whatever IP address our ISP gives us. Right? They have a router here. They're going to give us a public IP, and they'll have an IP that they use. So it will be on a piece of paper they give you. You'll give them a call, and they'll tell you. They'll have to give you something that says, okay, go to 68.110.171.90. Let's just say 99, right? Which would be the IP address of our ISP. So what that tells this router is says, if you don't know where to send something, go ahead and send it to them, because chances are it's out there somewhere in the great abyss of the internet. So millions and millions and millions of routes condensed into one statement known as a default route. Now let me add one more pointer to this and plug in a question. Well, let's say, right? Let me see if I can tactfully do this. Let's say that router 1 had a connection as well to the internet, right? And so it has that 68.110.171.90. Let's make it 90. Well, let's make it 100. 100 address, right? And so it's connected to the ISP. So we've got see if you can follow where I'm going here. We've got a static route that says here's how you get to the 192.168.3 network. Over you go that way. But then I go on router 1 and I type in the same default route. Right? That's what I would do. I would go to router 1 and I would say, but to get to everything 0, go here. Right? So Happy Computer on the left comes in and pings 192.168.3.50, which is this guy over here. Packet comes to router 1, who is Happy Computer's default gateway. Router 1 now looks at its routing table to figure out where to go, and it says, okay, well, it looks like he pinged 192.168.3.50. It looks like I have a route that says for 192.168.3. anything, go ahead and send it over here, right? But then I look and I have now a second route, and it says send everything to the internet. Okay, problem. Which does router 1 choose? Now, you and I looking at the picture are like, well, duh, it's over there on the right-hand side. You go that way. But you got to think like a machine here. The machine doesn't know that. The machine is like, I have one route that says go this way, and I have another route that looks just as tasty, and it's saying go this way. Which one is better? We come to the rule number 1 of routing. And this is, I would say, a hugely important rule that so often gets missed. It is the rule of, and I'm going to make it up. If it's not a word, it needs to be. It's the rule of specificity. Specificity. The more specific a route is, the better it is. Right? Look at this route over on here. I say IP route 192.168.3.0 with this subnet mask. This is what specifies the specificity. I'm going to patent that word. You like it, don't you? That's what specifies the specificity. That's how specific the route is. It says I'm a class C subnet mask. This one down here says I'm a class nothing. I'm essentially a catch-all. I'm not specific at all. So I mean, let's make it a little more pertinent. Let's say I put another static route in router 1, and I say router 1 to reach 192.168.0.0 with a subnet mask of 255.255.0.0. Right? We kind of slap a class C subnet mask on a class or a class B subnet mask on a class C address. So essentially this says to reach anything starting with 192.168 and then anything after that, go ahead and go this way. My thing is just turning into a big chicken scratch. And meanwhile, I still have this route 192.168.3.0, which says go this way. Right? So if I'm stuck in that world, if I'm stuck in that decision on router 1, which one's going to win? It's the rule of specificity. I can't even say my own word. Specificity says this one is more specific because it's a more specific subnet mask. Thus, I'm going to go that direction. Now, if now you guys are subnetting masters, right? But if I created a third route on router 1 and I said to reach 192.168.0.0, sorry, let me back that up. To reach 192.168.3.0 with a subnet mask of 255.255.255.128. Think back to your subnetting skills. What does that do? That actually cuts this network in half. You have two networks then. 192.168.3.0 through 127 is one network, network 1. And 192.168.3.128 through 255 becomes network 2. That's what that subnet mask does. So if I created that subnet mask and I said, okay, to reach 192.168.3.0, 255.255.255.128, go that way out to the internet, now we have a problem, right? Because when this guy pings 192.168.3.50, it comes into router 1. Router 1 says, okay, I have a route 192.168.3.0 with a class C subnet mask saying go that way, but now I have a more specific one. I have a route saying 192.168.3.0 with a /25, a more specific subnet mask that says go this way, so now this guy ends up routing out to the internet. Well, let's put these concepts together with a little demonstration. What I've got here is a small scenario. We've got three routers. Router 1, 2, and 3 connected all around the different networks. Now, all that has been done to these routers is given them a base configuration. And what I mean by base is given them a host name, set the console port to logging synchronous and that kind of thing. Gave them IP addresses, 192.168.3.1 and 192.168.2.1 for router 2. And then over here on router 1, you can see, this guy's 192.168.2.1 and 192.168.1.2. Now, sometimes I find early on in the Cisco career, because I remember it happened to me, a lot of times I would just start seeing these diagrams and I would become numb to the real world. I'm like, they are hockey pucks on a screen with some squares and clouds. What is this like? So this would be an organization. Maybe it's a small organization that's starting to grow. Maybe they had an office originally. This would be an office right here. And that would be in California. Right? So they've got, maybe 50 users sitting here on this network, and they originally had an internet router that was allowing this site to access the internet. But they eventually started growing, and they're like, hey, we're going to move out to Texas because we saw some customers over there. So they bought a small little Texas office, 20 or so users sitting at that location, and they just brought up a 192.168.3.0. Again, very, very usually when you see 192.168 addressing, you're like, okay, this is kind of like a small office, homegrown mom and pop shop sort of office. It's just, again, just the generality of where you see these 192.168 addresses used. So they now are like, okay, well, we want to connect our office in California to our office in Texas. Cisco consultant Bob, can you make that happen? So that's where you come into play. So where I would start in, I guess, and I stripped all these things down. So all these have just base configurations. I don't even have a default route to the ISP, which would normally be there. Would this have been a real company? So we're going to go from scratch. After we've assigned the IP addresses, what to do from there. I'm going to start on router 1 for no other reason than the fact that it says router 1, and that's where you're supposed to start. So I'm going to go on there and just get familiar, first of all. Let's bring router 1 into the picture. And just so I can still see the IP addresses, I'm going to do a show IP interface brief. And I'm identifying, okay, serial 0/0, which is this guy right there, is 192.168.2.1, so that's verified. And I've got fast Ethernet 0/1, which is connected over here. That's 192.168.1.2. Router 3 is 1.1. So I'm just going to, I want to make sure that I can ping. I'm going to do some pings, 192.168.1.1. That would reach up to router 3. Sure enough, I'm successful. So this little communication is check. And then I would jump over here to this bridge, and let's just ping 192.168.2.2, which reaches out to router 2. Okay, so we've got a little check there. Now, I'm just going to do something really simple. I'm going to ping a little beyond to 192.168.3.1, right? Which is connected to router 2. Should router 1 know how to reach that? No, it will not. But let's prove it. 3.1. And it comes back and it's sitting there with the periods. Fail. The periods mean request timed out. We're not getting there. I don't know how to get to that destination. And rightly so, because 192.168.3.0 is not directly connected. Let's do a new command. I'm going to do a show IP route. This command is the lifeblood of your router. It shows every single network that the router knows how to reach. And when I look here, it says, okay, I only know how to reach 192.168.1.0/24 because I'm plugged into it, directly connected, right out this port. You see the little C? Look up at the code. C is connected. So I'm plugged into it. I also know how to reach 192.168.2.0. It's right there, serial 0/0. Why? Because I'm plugged into it. Now, how does it know it's plugged into it? Because at some point, you and I would have gotten on this router, and we would have assigned an IP address. And as soon as we assign that IP address, the router goes, oh, that's what I'm plugged into. Right? You follow that? So now I need to educate this router. I need to say, hey, router, here's how you get to 192.168.3.0. Let's do it. I'm going to go config T. Global config, and then this is the command I just showed you on the previous slide. IP route So I'm going to say, I want to route. Now, where am I going? And there's all these other options that we have here. But the main one I'm interested in is the destination. I want to reach 192.168.3.0. The router says, oh, yeah? Well, what's its subnet mask? 255.255.255.0, or prefix mask. Same thing. So class C subnet mask. And then it says, okay, well, how do I get there? Now, there's a couple ways I could go about this. I could say, well, go ahead and send it out serial 0/0. And that would work okay. But I don't like that. It's too, I don't know, too vague. When I deal with routers, I deal with layer 3. I don't like just saying, yeah, go out that interface. Just go. Like I feel like, when we moved into my house, we found these 3 cats, and we kept one of them, but the other 2 we had to let go, and we kind of took them to the door, and we're like, okay, go Cougar, go Modak, go, bye, see ya, bye. Door slammed. That's what I feel like. Is if I say to get to this network, go out serial 0/0. While that may be accurate, it feels like the router is kind of like, okay, open the door, go little packets, go find your home. Okay, go. Now, it'll work in this case because it's a point-to-point link. And it'll reach the other side successfully because that's the only, it's kind of like it just fell into a tube and it happened to go that direction. It's kind of like there's no other way to go, so that's where the little cats went. But the best way to do it, and I'm saying just to avoid troubles, to avoid weirdness, is to point it to the actual IP address. Don't say go out this interface. Tell it to reach this network, go to 192.168.2.2. Again, just from the last slide, this is going to something that you know, 192.168.2.2, to reach something that you didn't previously know, 192.168.3, right? Good. So now let's test it. So previously I did the ping to 2.2, successful, and then I went to 3.1 and that failed. Let's try it now. Now we are successful, right? Because it knows I have to go through 2.2 to reach 3.1. We can even do let me do this. I'm going to do a no IP domain lookup. That's a command that keeps it from trying to look up next hop domain names, which just slows this command down to no end. But I'm going to do a traceroute. Traceroute 192.168.3.1, and it just shows that, okay, it's only one hop away, and I went through this IP address to get there. Just again verifies that we went there, and it always pings 3 times. It always loses the second ping on traceroute, the final leg of the thing. There's actually a whole article Cisco wrote up of why that is, but for now, that's the way that we get there. Now, here's another scenario. Let me do this. I'm going to do show IP interface brief, right? Again, router 1, and I'm going to do the same thing, ping 192.168.2.2, right? Feeling good about that, but I'm going to add to it from the source, and I'm going to say come from the source fast Ethernet 0/1. Now what is that? 192.168.1.2. Now why am I doing that? Because what I'm saying is when this guy pings this guy, it's of course going to come from this source because it's saying, okay, my source IP address is 192.168.2.1. That's the interface that I'm originating this from, and I'm going out and I'm going to the destination of 192.168.2.2. That should work just fine. But I'm changing the game. I'm saying, no. How about you come from the source 192.168.1.2, come from this IP address as your source, and try and ping that same destination. What do you think will happen? Success or fail? It's going to fail. Why? Well, because even though it's coming in the same link right here to router 2, and you can watch the dots appearing there, even though it's going in that same link, router 2 now is getting packets from the source 192.168.1.2. It's looking at its routing table, and it's saying, do I know how to get to 192.168.1.anything? No, nobody has told me how to get there. So the packets are getting there and they're being dropped. The 5 drops, it does not know what to do with them. So what do we need to do? Got to go to router 2, right? Let's do that. Router 2 is in the game, and we will do show IP route. I see router 2 is not very smart. It only knows about its two connected interfaces, 2.0 and 3.0, which we configured it from the beginning. So I need to go into that router 2, and come on, if you know this, pause the nugget now and write this command. Write down what I'm going to type in here. Write down what will fix this. Okay, unpause. IP route 192.168.1.0. Even though I want to specifically reach 1.2, routers don't do that. While they can, I don't want to do that. I want to say to reach that whole network, to reach everything on that network with a 255.255.255.0. Router 2, you need to go to 192.168.2.1. Again, router 2 knows how to get here, right, to the 1. So we're saying use that guy because he knows how to reach 192.168.1.0. It's like a big train that we're building. You know, one by one by one, we bring these links up. So now I can come back to router 1 and do the same command. You know, ping him again from a source of 192.168.1.2, and now we have success. Why? Because router 2 knows how to get back. He's saying, okay, now it's coming from this source, and somebody just educated me how to reach this entire network. Now, what about router 3? Router 3 up here has been out in the cold. He doesn't really know anything. I mean, well, he knows how to get to his connected network, 192.168.1.0. Right? And he knows how to get to his ISP, not the internet. He just knows how to get to this network between him and the ISP. So he's got a lot of work that we need to do for him, right? So it should be pretty fast now that we know what we're doing. So let me just clear off all this gibberish, and let's go to router 3. Here we are in this blank little config screen. Let's do a show IP interface brief on him, and we see, yep, he knows how to get to his ISP. He's on that network, and he knows how to reach the 192.168.1 network. But if I do a show IP route, he doesn't know anything else. So he can't get to, he doesn't know how to reach this WAN link, 192.168.682, or this network over here. And I just prove it to you quickly, 192.168.2.1. We're not getting anywhere. He doesn't know how. Control-Shift-6, by the way, will break you out of a ping that's stuck if you don't want to wait for all of it to fail. Control-Shift-6. You have to hold it all down, you know, kind of hit them all at the same time. All right, so I can add some routes. So I'm going to do IP route. Again, pause the nugget if you know where I'm going and think through it. 192.168.2.0. So to reach the 2 network, 255.255.255.0. Go to, who's he going to? 192.168.1.2. I'm saying go here in order to reach here, right? Now some of you might be looking at this switch being like, well, what role does he play? Cable connector. That's about it. I mean, if normally you actually won't even see this drawn. By the way, these guys are all peripheral. If you download the GNS3 topology that I'm using to create this scenario, these I don't even know if I put a configuration on these guys. They're just there for the picture. But photo op, right? But this guy is normally drawn. The people don't even draw him. You see diagrams like this. To where you see, you know, these guys. So the switch just becomes the line because all that guy is kind of connecting everything together. He doesn't really participate. We're going through him. He learns the MAC addresses, but we're talking layer 3. We're dealing with IP addresses. All that stuff is now assumed. That was earlier in the series. So we can come back here, hit the up arrow. Well, let's just prove it now. I'm going to do a ping 192.168.2.1. Groovy, we're getting there. Let's go 2.2. Groovy, so we're able to reach everything on that 2 network. But what about 3.1 now? Fail, nothing, not getting there. So Control-Shift-6, break that, hit the up arrow a couple times. There's my static route. And I'm going to say to get to 3.0, that network over there on the right, go to 192.168.1, same place. Because router 1 has a static route that gets them there too. Put it in place. Bam. Look at that. It's kind of cool to do static route. It's definitely one of those, like, I've accomplished something today feelings. Because you really are bringing up networks. Now, this works great for networks the size of what we're looking at on the screen. But the more and more this grows, you add 4, 5, 6 routers. I mean, the amount of work you have to do begins to increase exponentially. Every new site that's added, you have to go to every location, every router, and say, okay, to get here, do this, do this, do this. Now, the key about static routing is it's good. It works well. You just need to know when to convert from it. You got to say, okay, it's time to make a leap from static routing to something else, and that's going to be what we talk about in the next nugget as we get into dynamic routing. One more piece that's missing though, router 3. Yeah, he's got an internet connection, meaning the ISP is coming in right here on this cable, but we don't have a route to reach the internet. So what I need to do is go in here and do IP route. Remember I was saying a default route. Everything zeros. Everything zeros. 68.110.171.99. Enter. Now I'm assuming, this just made a big assumption, that the ISP is actually 99. Now, let me just say, in this scenario, there is no ISP. And when I went into GNS3 and created this, I actually converted one of my computers and just said, no, you're a cloud. And it's not really a cloud. It's just a computer. I just said, look like a cloud. But it's not real. But that's the only thing that I would have to do to bring up that internet connection. Now, I'm not going any further. I'm not making this internet connectivity real, and I will later in the series, because there's other things that have to be in place to make this whole thing work, primarily the one being NAT, network address translation. We haven't gone there yet. Now all of these other routers, because I'm using static routing, need a default route too. Right? So I'd have to go, this is the beauty of static if you're paid by the hour. You go in there now to router 1 and I say, okay, IP route, to get to the internet for you, from your perspective, go to 192.168.1.1. Right? So because from router 1's perspective, he's going to router 3. And from router 2's perspective, right here, do a show IP route on him. He only knows how to reach, he's got static. You see that? 192.168.1.0. By the way, we haven't talked much about this yet. We will. This actually represents the administrative distance and the metric. When we get to the next nugget, we'll start looking at, actually, did I put that in? I think I did. What administrative distance is, how believable is this route? 1 is actually a really, 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 really good administrative distance. That's like almost the best that you can get, because you as an administrator told this router, this is what you do, router. And the router, sometimes to its detriment, believes you and me. The second one is the metric, as in how costly is this route. That's when we start talking about how does the router find the best route. It's going to be the one with the lowest cost. Now this looks like a really, really, really good route because it has a cost of 0. But more on that later. So it's saying to reach this guy with really good administrative distance and really good cost, go to here. And it will. So we now have to add in. But to get to everything else, go to 192.168.2.1. Again, router 2, from its perspective, he says, I'm going to send everything to here. And router 1 says, well, I've been configured to send everything to here. And router 3 says, well, I've been configured to send everything to here. So you kind of create this chain of send everything. And now when I do a show IP route on any of these routers, this is the first one I'll show you, you can see that I have this static. Notice the little star. The star, if we look at the key, says candidate default. And you also notice previously, it was saying, I don't know where I'm going. I don't have a gateway of last resort. Like, I don't know how to get there. I'm sending it here. But notice after we put in the static route, it's saying, okay, now I do. Now I know if everything else fails, last resort, it's kind of like if all else fails, I'm going to send the packet to 192.168.2.1 because that's what I was just configured with that default route. So you can think of static routing like a big scavenger hunt. You ever done a scavenger hunt where you either have probably a team of people that's with you, and you get envelope number 1, and in the envelope it says go to a store in the mall that starts with the letter sport, I guess that's obviously I didn't do that many scavenger hunt. Starts with the word sport, right? And so you go to the store in the mall, and the store in the mall you find another envelope there, and it's like, okay, now go to the, you know what I mean? So you kind of keep going with all these envelopes until you are the first and you win a prize, and that's really what static routing is we're kind of creating all of these little links. That's the feel that you get as you configure these devices. It's like, okay, to get to the 192.168, go here, and when you get there, they're like, no, 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 actually go here. But you as the router, you as the administrator have to go in there and statically place each one of those envelopes. In one sense, it's good because you have complete control over everything, and if something fails, it's your fault. You know that you did something wrong. It's very simple when you look at static routing. But also from a overhead perspective, you can see that can really start being a lot of work, especially when you start having many different paths in your organization and many different sites. It just becomes plain overwhelming. So static routing works well for small organizations, not so well for large. That being said, you almost always find it in every company in some form. You'll find some device with the static route put in there. So we have seen in this nugget the purpose of routing, kind of taking us back, big picture, what is routing. We looked at how static routing can help us accomplish our goal of educating the routers manually, and then we looked at some configuration and design scenarios for static routing. I hope this has been informative for you, and I'd like to thank you for viewing.